Hey, have you ever heard of the term differentiation? No? Okay, maybe dy dx. Still no? Okay. Maybe I've heard of the gradient. Okay, we can start from there. Okay, let's get into what differentiation is. So suppose you have a line, or straight line that is, and you have a point. Let's label that as x1, y1. Then let's also get another point, and let's call that x2, y2. Okay, cool. Now, this line has a special property which is called the gradient, which is just the steepness of the line. And we find the gradient by getting the rise, how much the line has risen, which is also termed as the increase in y, divided by the run, which is the increase in x. So let's just substitute that back. We have increase in y divided by increase in x. Yeah, that's a delta, by the way, increase. Okay, so we have those 2 points right there. So that point right there is x1, and that other one is x2. Then we also have these other points, that's y1 and that's y2. Okay, and therefore, since our rise, which is our increase in y, that's going to give us y2 minus y1, divided by our run, which is going to give us x2 minus x1. And that right there is how we find the gradient of the line. Okay, now let's move on. And let's talk about the gradient of curves, because in real life you won't always have straight lines. Sometimes you have some curves, you know what I mean? Yeah. So let's say we have that parabola, and then let's say one finds the gradient of a certain point. Let's say that point. So in order for us to find that, we need to find the tangent, the line which only touches one point of the curve, and we need to find the gradient of that line, and the gradient of that line is going to be equal to the gradient at that point. So yeah, the rise divided by the run. So if one did find the gradient at that point, you also need to draw another tangent and divide it by the rise, divide the rise by the run. If one did find the gradient of that point, yeah, we do the same thing. What I'm just trying to say is that drawing tangents and finding the gradients of each point is kind of tedious. So we need to use differentiation, which is the process of finding a certain function which is going to give you other gradients. So we represent this as dy dx, or the gradient function. So this gradient function gives us the gradient, or specifically a function which will enable us to find the gradient. So let me give an example of this. Okay, let me draw another graph. Okay, y-axis, x-axis, and we say y is equal to x raised to the power of 2. So the gradient function of this line is going to be dy dx. That's going to give us 2x. But I'm going to get to how we're finding the 2x. Let me just show how it works. So suppose we have a point 1, and we want to find the gradient of that point when x equals 1. So the gradient is going to be equal to 2 multiplied by 1. Just substitute that 1, the x at that point, and then that's going to give us 2. So if we draw a tangent to that point, the gradient would give us 2. You see that, right? Okay. Now, let's get into how we even got the gradient function in the first place. So suppose we have an equation y equals ax raised to the power of n. In order for us to find the dy dx, or the gradient function, we need to multiply a by n, the power by the coefficient, and then we're going to reduce the power by 1. Yeah, and that's how we find the gradient function. So in that case, where it was x raised to the power of 2, multiply 1 by 2, and then reduce 2 by 1.